welcome back to Blueprint Reading for Welders, the welding section of this course. My name is Evan Rodolescu again. I'm the welding instructor here at Kilgore College, or one of them. Today we're going to be going over Chapter 2 of our Print Reading for Welders book, or Unit 2, and we're going to go over sketches, all right? So what is a sketch? A sketch is just a freehand drawing that you mock up the idea for whatever you're building. Let's say you're building a bookcase and you have no idea how many shelves you want to put on it. Well, draw it out real quick and give you an idea of what you're trying to build first. If you're trying to build a trailer, you want to sketch something out first before you actually just jump right in and start throwing things together. A good sketch to work from helps you build around that so you don't waste time or you waste material on anything that's not really necessary, okay? So sketch, by definition, is a freehand drawing used to describe the shape and size of an object. You can quickly express any idea, maybe translate it into a finished drawing. Any quick sketch that you make can be turned into a full-on drawing later on, but usually whenever you're doing sketching, you're doing it free-handed. You can use a ruler to help you draw straight lines on anything, but usually with a sketch, you're going to be just doing a freehand drawing and you aren't too worried about your lines being straight. You're just trying to quickly show what your idea is. It's going to be used, sketches can be used in place of finished drawings, and they often have been, but they'll have dimensions on the side or anything like that as you're going along. The size of an object in a sketch is usually proportional to each other. If you're building a trailer and you draw, let's say you want to build a trailer real quick, you're going to draw two wheels, and then you're going to draw maybe let's say that's a 20-foot trailer. Those wheels are going to be proportional to the rest of the trailer because it's easier to understand the size of it if you have something that's in proportion. You're not going to draw two wheels that are huge and then say that's a 20-foot trailer when the wheels are clearly so much larger, because those would be probably 3-foot tall tires on a 20-foot trailer, or even 5-foot size tires on a 20-foot trailer. That wouldn't be any good. So usually when you're drawing or you're sketching, you try to keep everything in proportion to each other so it's easier to understand as you're going along. Details that need to be fabricated on an object can be added to a sketch or are added to a sketch later on, and you'll apply those details as you're going along. Lines slightly sketched with short overlapping strokes. Use a pencil with a sharp point while you're doing this. So whenever you're sketching, you can just do short little strokes like that. You're going to overlap them slightly. So if you're drawing a square, and if you want to, you can come back with a heavier pencil and draw over those earlier lines, give you a better look. And as you're drawing this, if you need to make a hidden line or you need to make an object line, you can come back later while you're drawing it and add the appropriate line weight to them or to that drawing later. To make a heavier line, you can either use a larger pencil lead. I've got two pencils here. One is an 0.03, one of these pencils is a 0.3 pencil lead, so it draws much finer lines. Well, I've got another pencil here that's a larger lead on it, so it'll draw heavier lines. To do this with a pencil, you can either keep a very sharp point on your pencil while you're drawing, or you can round it so you can get heavier lines as well. And it also has to do with the amount of pressure you apply. A light pressure gives you a lighter line, a heavier pressure gives you a heavier line. So drawing half circles, full circles, or arcs can be difficult free-handed to get them even, so you can draw yourself a little framework before you draw it out. All you have to do is just draw a quick right angle And it's almost like you're drawing a box, and you mark a point and a point, and then you kind of follow that arc that way, and you can add, let's say if you draw a straight line there, got your line here, and then you make a little triangle, put one dot in the middle of that triangle, and then you follow that point to that dot, and you just draw along like that, and that'll give you a quick little arc, just like that. So you draw your little frame, draw two dots, and that'll help you draw your arc, trying to go to that point. All right. So to help us draw arcs or lines, we draw a quick little framework for ourselves, two little right angles, and I'm going to place a dot about evenly from each space, and you can just follow that and kind of stick close to those lines. And then whenever you're done and you've got the arc you want, you go back and you just erase those lines, those extra lines, that extra framework, and that'll help you whenever you're drawing arcs or circles or anything like that. You can also, that one I just did 2 points on the right angle. You can also draw your two right angles. Put your point there, draw a line straight across, and you'll give yourself a triangle. Now you find that point where it looks to be about the center of that triangle, and you can go through and draw your arc. You go to that point, and then to your other point. Follow that line back. And then you go back in, and you erase all the lines that you didn't need later for your quick little sketch of that arc or that circle. Now if you need to sketch out a curve that goes one way and then the other, all you have to do is draw your right-handed framework like this. And whenever I say right-handed or a right angle, it means this is 90 degrees. And then you can draw another one going the opposite way, or you can go off of this arc here and then down and give yourself another right angle there. Here's that real quick. So we've got 1 point here, 1 point here, and then a third point here. And we draw our arc going down to that point. And then we can draw from that point down to the next point. And it'll help give us a curved line anytime we're trying to draw free-handed. Now, one of the other ways you can draw a circle to help you draw better circles whenever you're sketching, you can start by drawing yourself a square. All right. And then we are going to draw an X within it, point to point. Find the midpoints there, 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 and there. Now you can draw even more lines if you want to help continue to draw this out. You can draw from those center points up here to here. Trying to use as little pressure as I can. Still leave a mark. So just like earlier, whenever I was trying to find the center of those triangles, I've got one triangle here, there's the center of it, another triangle here, there's the center of it, another triangle here, there's about the center of that triangle. And then from all those points, we start to draw our curve. Instead, you get a circle. I probably would have done better just drawing a circle that way. But this is one of the ways they try to teach you whenever you're sketching out in the book. Really though, the best way to draw a circle is to get a compass. That's really the best way to draw a circle. Just use a compass. So for drawing oblique sketching from an orthographic drawing, we're going to take the 3 orthographic views we've gone over earlier. We've got our front, top, and right side. We're going to take the view that best describes the object and shows it in detail, and we're going to draw receding lines at about a 45-degree angle from the corner of those views. We're going to draw to the right from the right oblique drawing and draw to the left for a left oblique drawing. So I'm going to try and do a right oblique drawing. It may look left to y'all. And what it's going to basically be is if I had a T-joint, and I'm going to use graph paper because that enables me to draw this a lot better. Lines for the object, whatever you draw with an oblique drawing, you normally are only going to see what you can actually visibly view it. They aren't going to draw too many hidden lines as they draw this. You're only going to see the object lines or what you can actually view from that angle. So for a T-joint, draw from the base plate. I'm going to go up 2 parts, 2 squares on each side, and then draw across. So that would be the base plate for my T-joint. And then I'm going to go up right over 2 and then down. So I'm about 1, 2, 3, 4, 5, 6 squares high, and then 1, 2, 3, 4, 5, 6, 7, 8 squares wide, all right? So I'm going to draw this to the right, and I'm going to draw these lines in a receding pattern right at 45. So draw back this way, right across the squares. I've gone through 1, 2, 3, 4. So to bring this line back this way, I need to go through 1, 2, 3, 4. And you can see from this point here to this point here, I'm 3 squares across. So 1, 2, 3. I will do the same over here. So 1, 2, 3. And then I was 6 squares tall back here. So 1, 2, 3, 4, 5, 6. And then I'm just going to draw right across, and that's 4 squares there. If I draw another 4 squares across here, and then 2 squares across the top, because this piece is 2 square wise, you can start to see the oblique drawing taking shape. And then I'm going to draw this back here. Now, you don't see this as it's proceeding behind. What I'm drawing is basically a 3-dimensional oblique representation of that orthographic. So what we had was our front, our right side, and then our top. And that's translating from our front side view that would have looked like this. So So that would be our front side. And then from the right side view, I'm going to move it a few squares over. So this would represent our base plate right here. And we would have another line going straight up and to the right and straight down. Because this piece, this top piece right here that's sitting on top of the plate is the same length as the base plate. And then a top view would look about like this. Draw our square for our base plate. Let's call this part A. And this will be part B. So this square would represent part A, and the part that goes on top of it is part B. So from our three orthographic views right here, front, right, and top view, we can turn that into an oblique drawing that's all drawn on these 45s. So we've got our front view here. This would be our right side view. You would see this plane and this plane right here, that's represented here and here. So I'm going to highlight these so that they're easier to understand. So for my front view, I'm going to highlight that section blue. And what I'm highlighting are these planes, or the flat surfaces. So all that represented blue right there, I'm going to color this in or highlight it in blue as well. So you understand that plane there is for the front view. Now for the right side view, I'll highlight this color here for these planes. Fill that in real quick. So for this oblique drawing, this would be our right side view. These are the planes that we would see from that angle. So front, right side, represented by the pink highlighter. And then for the yellow, for the top side view, these would be the planes that we would see from the top view. Now, if you've noticed, whenever I've drawn these obliques, I haven't gone back. I drew these, they're about, what was that, 16 blocks long? I only drew back about 4 blocks on these at an angle, because whenever you make an oblique drawing, you don't actually have to draw back all the way. There's a lot of space that you can save by shortening it in that three-dimensional form. Now, I said earlier in the first video, when you draw an oblique, it kind of warps this. So in reality, this is like you took the first plane, which would be the front top right here, the front view here, and you've kind of shifted it to the right, and then you shifted it upward. And that's why it kind of has this strange appearance to it. In real life, this would be kind of wonky looking. So for oblique sketching, it's very simple to draw out like this whenever you've got standard graph paper. So the advantage with oblique drawings are that you can do it on just any old graphing paper that you have lying around. Now I can draw broken lines. If I wanted to draw a hidden line back here, if I drew a small hidden line going back, I could represent that last part of the edge that you're not going to see, but that starts to clutter up the oblique sketch. And you can draw circles and cubes and spheres with this technique, but it's kind of difficult and a pain in the butt to do. But in oblique sketching, everything's breaking off either a 90-degree or a 45-degree angle. So these edges here are on the 45 because they are the receding lines going back. And these edges here on the front and going up are at 90-degree angles from each other because they're the verticals. They're the non-receding lines. Now I'm going to show you how we drew out this orthographic T-joint where we had our front, right, and top view. I'm going to show you how to draw it in an isometric view or an isometric sketch instead. Now, an isometric graph paper, you want to use this whenever you're drawing isometrically. It's just like our regular graph paper, but instead we've also got lines going through it as well, and this helps set our object at 30 degrees. And it really is useful whenever drawing out for isometric style sketching. So for isometric sketching, it varies from oblique sketching because all the angles are going to be based off of 30-degree lines instead of 90 and a 45. Isometric graph paper like this, all these lines are set at 30-degree angles, and they're a little bit easier to draw with, and it warps the image less. View of the objects are best show shapes in detail drawn at 30-degree angles, and we're going to have parallel receding lines stretched at 30-degree angles from each corner. Only visible part of the objects are usually sketched. We're not normally going to sketch hidden lines. All you're going to see are object lines or what's actually visible from that angle. So when the surface of an object lie on different planes, start from the front face, then you're going to develop each portion progressively to the back face. So we're going to start from the front and we're going to work our way to the back. So the start of this object, I'm going to start at this left corner right here. I'm going to draw two squares up. Use this one instead. And I'm going to go a few squares across. So 1, 2, 3, 4, 5. Let's go 6. I'm going to go down 2. And then back across. So what I've just drawn there is I've started at my left corner right here on our front view, and I've gone up to our right, and that is this plane right here that I've drawn here. Now for the center part of the T, up this way, and we'll go across 2, and then back down. All right, so this is our front view right here. And then we're going to go up and off to the left. And up and off to the left again. One, 2, 3, 4, 5, 6. And first off, go 1, 2, 1, 2, 3, 4, 5, 6. Draw our next receding line. 2, 3, 4, 5, and 6. Draw the line connecting those two right there. 1, 2, 3, 4, 5, 6. Draw a line going down. Cross. Down again, and we've got another receding line going out to the distance there. So this is our isometric view. Everything is on a 30-degree angle. And I'll highlight this again so that you can more easily tell the planes apart. So here's our front plane. It's going to be blue. And this would actually be a left side plane that I'm drawing in on the pink, but it's going to be our side view. Draw that in. and then visible from the top. So that's the main difference between an oblique sketch and an isometric sketch. On this oblique, everything is either at a 90 or a 45, but then on the isometric over here is everything's based off of a 30-degree angle. Let me draw that real quick. So if we consider this our flat plane here, we've got 30 degrees here and about 30 degrees here. And then up here at this angle, we'd go another 30. Well, that's parallel to this angle, so that's based off the 30 there. And then the top angle itself, so for the isometric, we have 30 degrees here for one plane, 30 degrees for, let's call this our front plane. We've got it based off 30 degrees. Then for our side view plane, we've got that off of 30 degrees. And then for our top plane, it goes another 30 degrees based off of that. So. Actually, no, it's all based off of the front and the side. So with isometric sketching, I consider it to be more true to life because it doesn't warp the image to the side. This is a more true representation. This is why I like isometric drawings a little bit more than oblique drawings. That, and whenever you've got isometric paper, it's a little bit, it is difficult to draw without isometric graph paper, but once you have it and you've done it a few times, converting an orthographic where you take your three views into an isometric is pretty simple and straightforward. There's a few good examples in the book later in the chapter whenever you're doing your homework where you're going to have to look at an orthographic and you're going to have to see or draw and turn it into an oblique or an isometric, or look at an isometric or an oblique sketch and turn that into one of the orthographic views where they're asking you to take this isometric and draw out what would this look like from the top view down. Well, you know, you've got this plane here, and this plane here, and they're drawn out just like this T-joint, so you could draw out what that top view would look like as an orthographic.